Aren't I? Okay, here we go. So, side splitting theorem, okay? What we have here are a bunch of parallel lines, 3 in this case, and they're cut by a couple of transversals. Well, one thing you know about all these angles, right? That's fine. But when we have this situation and the sides of, say, that big triangle are split like that with parallel lines, well, you know that parallel lines are always how far apart? The same distance apart everywhere, right? Okay? So we've got all sorts of proportions we can set up here, right? So BC to CD, right? If we compare BC to CD, that would be in the same ratio as what corresponds here on the other side. GF and FE, right? Okay? And there's a million more, right? So if we go BC now, BC to GF, that would correspond to BD to what? That whole thing over there. You getting the idea? Okay? So now that we know, and this only works when we know the lines are parallel. In the one before Liberty, we could have found some way to find those lines parallel. We could have, if we found them to be parallel, like with corresponding angles, then we could have done the segments like you want to do here, right? That makes sense? Okay? So, and I'm not going to go through all of these, right? But I will say that we do have to still keep in mind the fact that, let's say you're looking for, say, like this segment here, which is part of an entire triangle, isn't it? Right? And so then if you're going to get something to correspond on the sides, it has to be like an entire side. You'll see what I mean when we get to some of those, okay? So in that sense, it will operate kind of like we did before. But we now have the flexibility to just set up the ratio, the proportions with the corresponding segments, okay? All right, so let's take a look at it. Let's just fill in the blank on these. So here's our diagram, parallel lines, transversals. So BY over BD, so here's BY, and then BD is a whole thing, would be in the same ratio as TM to what? TE. You're getting it, right? TE. They correspond and they are proportional if those lines are parallel, okay? All right, now over here, let me clear this out. I want to make a mess of it. AY. Where is A? A's down here. AY to AM corresponds to DY. EM. Right, to EM. And then we get TE to BD. So TE to BD corresponds to something over AD. AE. AE. Simple as that. It is. But you could probably guess it'll get a little more fun. All right. So you guys just take a second, fill in the boxes here for 1, 2, and 3, and make sure you can identify your corresponding stuff, okay? All right, how about number 1? We get
that one.
Yeah, that's number 1.
WQ.
WQ.
Yeah,
And the second one,
TW.
TW. Last one,
RK.
RK. There we go.
Let's go later.
All right, so now let's see what this does for us mathematically.
So this is going to get more complicated.
Okay? Well, we've been doing proportions, right? You know, cross multiply. It's not going to be that bad. Just have to be careful, a couple things. So in A here, see what the X is? We want to solve for X, right? Before, if we did not know these were parallel, we'd have to say, well, this is X plus 5 for the whole side, right? That kind of thing. And add those up over there. Remember doing that? But now they're parallel, so well, we can just do like, well, they do, oh, they're doing 6 over 5 equals 4.5 over X, right? You could also do what? X over 5 would correspond to what over what? Right? So there's a ton of different ways to set up your proportion for these and cross multiply and get the same answer, okay? Over in the next one, here's our X up here, right? So we could do X over 1.2 equals what over what? Could do 4 over 1. What did they do? They did 1.2 over 1 equals X correspondingly over 4, okay? Okay with that? All right. Now, on this one here, you got to be careful. So here's our x, right? But this is 9 over here, okay? That whole thing. So this whole double segment here is going to correspond to what over here? Now we got to do that. There is another way to do it, but our immediate look says we got to do that, right? So now our x is wrapped up in this expression x plus 6, right? So we can say 5 over this whole thing, 9, is going to be equal to 6 over the whole thing, x plus 6. Okay? And remember, that horizontal fraction bar is also a what? Grouping symbol. It's division, right? But it also acts like a set of parentheses. So it's 5 times the entire thing, distribute, and you know how to do that, right? Okay? These aren't too bad. What's the other way we probably could have done this? If you knew this was 9, then what's the length of that segment?
4.
4. We could have done it that way, right? So then we could have done like 5 over 4 equals 6 over x. Let's see if that gets the same answer. Let's do 5 over, let's just check it. 5 over 4 equals 6 over x, right? So 5x equals 24. Do we get 4.8? Probably. 4.9?
No, I don't know.
Oh. Should be 4.8, same as that.
Yeah.
Okay, you see what I mean? You just had to identify the length of that other segment there to do it that way. Okay, let's move down here. You guys are going to try these 3 here.
No.
They have an x and a y, some of them. So that's got an x and a y. Number 5 just has an x, and 6 just has an x. Okay? So take a minute. I'll tell you how I did it. Maybe you did it this way or not. I did x over 9 equals 13 over 15. Did anybody do it this way? Raise your hand.
I mean, I had the equation backwards, but.
Right, but see what I mean? You did it completely different segments, right? Probably got the same answer. Those parallel lines open up our flexibility, right? So we got 15x equals 117, 7.8. And how about for y? What'd you get?
18.2.
18.2. We go with that. Here's what I did. I did y over 21 equals 13 over 15. And you okay, that's fine, but you still got it, right? That's the flexibility here, isn't it? Right?
Yeah, it's really flexible.
So 15y equals 273. You say it was 18.2. Okay. How about 5? What's x equal?
4.
You didn't get 5?
I got
Oh,
4.
well, let's get that far.
I got 4
It
too.
is 4. See if you get 4.
I just got 4.
I got 4. 5 over x.
I don't know how to do 6 though.
That's what I did.
That's what I did too.
I didn't even mess with the 9. That's a 4, by the way. I want it to look like a 9.
Yeah. Otherwise, I would have made those work.
So I did x with 5, and then down here 4 and that 5.
Mr. Guthrie.
Yeah.
Can you use a different color?
You don't like that?
No.
What color do you want? Come on.
Anything besides blue. Like blue.
Yeah.
No, it's really just always blue in it. It's like right next to the.
Well, I usually use blue because most of the stuff in here is black.
No, most of
You're
it's
right.
blue.
Yeah, well, now there's something.
That's not bad.
Geez, Carter, why
What do you want that right there? Is this gonna make you happy?
Look at that.
So we got 5x equals 20. Is this better?
That looks nice.
I suppose.
Looks more bold. Better, easier to see.
How about the last one? What's x? Anybody?
I don't know.
I didn't. I don't know what to do.
You got Olivia?
I got,
How many got 5.625? Couple of you.
hold on.
Okay, I'll give you a second.
I don't even know what to do. I got.
Same thing you did all the other ones. You set up a proportion, cross multiply.
I know, but the one side has nothing on it.
Yeah, there's nothing on it.
It has the 18 for the whole thing.
Yeah.
And
You add the
So-
whole, you add the whole side together, maybe.
You need to fit, it's got to correspond to
Wait.
18, doesn't it?
18 plus X.
Guys, if you're going to use 18 on this side,
Then you just add all those. together.
aha!
I got it now.
Say what?
Listen, if you're sitting there drooling over this, 18 is this whole side here, right? What's that going to correspond to? That whole side.
I gotta add those together.
16.
Oh. I got
That's
How do you do
9
that?
equals 16.
No, extra 9416. You have to finish it. You're on the right stuff.
I think you added these sides and got 16 probably.
I got 5.625.
The answer is 5.625.
Action.
So I did x over 5 equals 18 over 16. Right. X goes with 5 and the 18 goes with the 16. Got it? Good? So I, what was that? Somebody just asked to be locked out there? No? Okay. All right, so we good with this?
It's not yourself.
Guys, stop thinking this is next thing. Here's where we got to be careful, just like when we were doing just the triangles before, right? So we figured out in that last one, we have to be careful with something. Sometimes we need an entire side, right? Now take a look at this one. Take a look at this one. The X is down here, right? Everybody see that?
Yes.
That X is the full side of a triangle, isn't it? Right? So would I be able to say X over 5 equals 14 over 7? Or the way they have it?
X over 5.
No.
I don't think so. Yeah.
Listen, we've got a triangle here. This, you got to be careful. X is the full side of one of the triangles.
Yeah, so that's it.
Is 14 the full side of one of the triangles? Would it correspond with that? No. Is 7? Well, 7 is, right?
Yeah.
So we can use that, right? But these two, and that one is also the full side of a triangle, is it not?
So could it be, wait, could it be X to 5? No.
So what I'm getting at is, can we use 14 in our proportion?
No.
Why not?
It's not the
It's not the full side
That
of a
means you have to
triangle.
add it, though.
X right here is on the full side of the triangle. So it's got to correspond with another full side. You get, make sense? Yeah. Yeah, right? Okay? So I would just say, note here, this is important. X and 5 are full sides of a triangle. That's the triangle symbol, okay? So we have to add this up here. What is 14 plus 7?
21.
21, okay? And now they do it down here, right? So they, again, they broke the two triangles out. It's the same up here, right? They just took the big one out and the little one out separately, okay? That's 21. See it now? So yeah, we do have more flexibility, but if the thing you're using is a full side of a triangle, you gotta have the full side to correspond with it, okay? So this would be like 7 over 21 equals 5 over x. When you solve that, I think you get x equals 15, okay? So, knowing that, everyone do number 7, keeping that caution in mind. Give you a minute.
Show us how to do it, Father.
Well, is x the full side of one of the triangles?
Yes.
Is 6.
Yes.
Yes.
So can we use this segment here?
No.
No. We need a full side of the big triangle, which is what? 14.
8 over 14 equals 6 over 9.
You could do that, or you could do x over 6
Oh, no, it's like it's no problem.
equals what? So we're doing big to small, right?
Yeah.
We're back to that now. See how we're connecting that with the triangles, right? So we're back to that. Would be 6 over 14, or 14 over 6, big to small.
Wait, 14 over 6?
8.
Yeah, I was saying.
14 over
that's
8.
what I did and I got it wrong.
Right. Well, I don't want to do like you did then.
Yeah.
You do. All right. So they cross both ways. We get 8x equals 84. X equals 10.5.
Let's go.
Okay? Right? If you're dealing with a full side of what triangle, you have to correspond it with another full side. Sometimes you got to add stuff up. Okay? I mean, fine. Like if X was over here, we wouldn't have to worry about doing it, right? Because then it's not. It's just that segment which would go with this 6 over here. Okay? All right. We're not doing the angle splitting thing. So let's go to look at some Regents questions, thinking about what we just learned. Okay? So let's read these over.
There's a lot of these.
Yeah. So our side splitter stuff requires parallel lines. When you're looking over number 1 here, I want you to think, do we have parallel lines so that we can just do segment to segment? We do. How do you know we do? It doesn't say that anywhere.
Because it's a trapezoid.
Oh, and what do we know about trapezoids?
One third of
If it's a trapezoid, we haven't spent a whole lot of time on it, but you know, it's got one, the bases of it are parallel. So that's now. See now we can use that side. We can just do segment to segment, right? What is it they want us to find? Find the measure of TR. I think I'll put my X here on TR. Or, by the way, could we just do it like we did with the triangles before? Where you could use the full size. I'll show you two different ways.
Please.
We get an answer?
One.
Yeah, just to be fair, because when it's a multiple choice answer, we'll say the actual value of the answer, because then I'm sitting there, my first reaction is you got X equals 1. Right? So just say, you said X equals 6?
yeah.
Uh-huh. It is X equals 6.
I knew it.
Okay, let's do it a couple different ways here. So we could do, well, X over 4. No, we don't have that there, right? Do we?
We have X over 6. So
So they gave us a full side, so one method's going to require the full side, so that would be 6, right? So we could do X over 4, right, equals 9 over 6, right? So 6X equals 36 equals 6. Now, let's think about it using the side. I'm going to complicate it up a little bit here, but I just want you to see it. Let's say I don't want to use the full side, right? If this whole segment is 9 and this part is X, what's the length of this segment? The whole thing is 9, that part is X, what's left for this? 9 minus X, isn't it?
Yeah.
Could I do it this way now with just the segments? Because now with the parallel lines? So give me a proportion now with just segments and disregard this 6 over here. What could we set up? How about X over 9 minus X equals what? Well, you probably did. Okay, that's fine, but it would have worked. The way I have it, what would it need to be? I got segment is equal.
4 over 2.
See? The lines are parallel, so now I could do that if I wanted to. I don't know if I want to or not, but right? So what I have, cross multiply, I got 2x equals 4 times 9 minus x, right? Distribute. So that's 36 minus 4x, right? I know, but I want you to see the possibility that the lines are parallel, okay? So add 4x to both sides. Okay, we get the same answer, okay? Right? Either way. Let's move on to number 2. Get things labeled in there. Whoopsie.
Oh, we're gonna.
Okay. All right, triangle, CB then point E, CB such that AC parallel. That's a parallel. AB is 15. And BC is 12, so this whole thing is 12. And EC is 7. Wants to find BD. X there for BD. You got choice 1? What was your proportion? Okay, careful. So X, this segment to that whole thing, does that correspond to that segment to the whole thing? Ah. We kind of need to know that segment.
So just -7, -12 by 7.
Oh! God, see what you just say?
Minus it is.
Subtract.
Okay, yes. Subtract 7 from 12.
I'll say minus.
Yeah.
It's not a verb.
You know, minus is a name.
It's pronounced Linus.
Linus, yeah. Short one, girl.
Ah, erase.
I miss those days.
-7, so this is 5. Now adjust your proportion correctly, right? How many got 6.25?
I got
You're so bad at these.
What was your proportion? Well, what was it?
well, I subtracted.
I want to be able to humiliate you.
I
Come on.
I got 6.25.
Remember, that's where learning happens. Did you set up the wrong proportion, or was it?
It's okay, I just
Math there.
subtracted it wrong.
Okay. All right. Well, that's the important thing, right?
I got
So we get 12x 7.5. Okay. Let's move along. All right. Read it over. Number 3. 2
I got
I got choice 4.
plus 1. 3.5. So then they want 88. So I'm going to put my x there. Do we need to know this whole side? Because the 18 is an entire side, right? So let's see. X over 18 is going to equal what over what?
1 over 4.5.
1 over 4.5, right? We could have done this the other way too, like the last one. I could have made that x and this would be 18 minus x and done it the longer way, right? Right? But why do that? So we get 4.5x equals 18, x equals 4.
I totally did.
I think I did that.
Five.
Did I do it different?
The burrito.
Okay.
Yeah, I did it different. I did it a little bit different. I switched
you do?
both around, and then
Uh-huh.
I did
Just tell me what you had.
You know what? I had X on the top of the other side. I had it
X over.
You ordered it.
X over 1,
So you did x over 1.
and then
Equals-
18 over 4.5.
Well, that's a side splitter. It's the corresponding segments. That over that equals 18 over, right?
Yeah.
Yeah, I told you. Remember the start of the lesson, there was a million different,
Yeah.
proportions to set up. So go on to number 4.
Yeah.
Mark our parallel. So AB. Please stop clapping. To DFC.
That was me opening this.
Oh,
Yeah.
and EDA.
Almost laughing.
Kind of like clapping.
It's me.
To CBG.
I about that life. I'm rolling bricks. Probably, yeah.
Okay, guys, what do you think? Given all those parallel things, which of those statements need to be true?
That one.
What do you think?
Bang. I think it's 3.
Why would you think it's 3? BAG? Well, before I even address it, what caused you to think it's 3?
Gotta get bad.
A, E, B. Because they're both triangles.
No, but it's similar, not kind of.
They're similar.
So he says one triangle DEF, that top one, congruent to, careful, you see it says congruent, right?
It looks like somebody-
To CBF. Now, we know how to, we gotta go back here, right? These are how we prove things congruent. Do we have any of that? We don't have any side legs, right? So, okay, they can't, so the first two congruent, can we eliminate those?
Yeah.
We're not giving anything about sides, so, right? So that kid says 4.
I said 4 too.
So we're saying DEF similar to AEB. The bigger one. EB. Well, what? Is angle E congruent to itself?
And corresponding.
Corresponding angles, right? So these are similar by what? Angle, angle. So it all ties together with parallel lines.
Good job.
All right, let's go to number 5. Read number 5. Stuff. Let's mark the parallel stuff. Well, I'd say first, before we could answer something about these proportions, we need to determine that the triangles are what? Similar, are they?
Yes, sir. Angle.
That pair,
Angle.
reflexive, right?
There's actually in because corresponding.
Yeah, and all the other ones up there too, right? Yeah, yep. So let's go. We got to establish they're similar before we can talk about proportion stuff.
3.
He says 3. So 3 says AC over BC. So that would be long leg to short leg of the small one, right?
No.
Equals BC. Well, that's not even part of the big one.
Yeah.
Over DE, right?
What am I doing wrong?
Silly Landon.
So we can't.
I left out
What do you think?
We know.
1.
1. So 1, we've got AC to BC. Again, long leg to short leg equals DE to AE. So think about this.
Yeah.
Small triangle, long leg to short leg equaling short leg to long leg.
Yeah. No, it's backwards.
Ah,
Like, really small.
so it's not 1.
2.
I'm just gonna say it's 3 in case one of us. That was though.
Three's already crossed out, I tried.
Or I mean 4. I'm gonna say 4. No,
So
it's
it's
definitely
not
not
1.
4.
You said 2?
Yeah, that's what I think it's 2.
4?
It's definitely
Let's check 2. Let's check 2. So AB, hypotenuse to AD to hypotenuse equals BC, short leg to DE, short leg.
It's definitely not 4.
So hypotenuse small to hypotenuse big equaling short leg small to short leg big.
Yep.
Does that work?
Yep.
And this is, by the way, not just with the similar triangles, this is side splitter. Because someone else was trying, remember when we were first learning the corresponding proportionality triangle, someone out there said, I'm going to do side to side, like stay within the triangle. I said, not quite yet. We're not ready for that. It's true. I don't know if you remember that, right? Well, why is it true now? Because now we have the side splitter thing. So whoever it was that said that before is now correct in a technical manner, right? Okay? So it is choice 2. Let's go to number 6.
I knew it was 2 1. That was my first choice.
BA unit drawn. EDs, get it labeled. 5. So you guys are doing this. I'm just labeling. 12. Should be old hat by now. And BE is 7. They want the length of BC. So that's X. There's a couple ways to do this. Let's do it. Now, somebody want to give me a proportion here? Go ahead.
5 over 17 and 70 reps.
17.
Yeah, where'd you get 17 from?
5 plus 12.
Ah, because the X is a full side, isn't it?
Small. Yeah.
So he's doing 5 over 17 equals, you said 7 over x?
Yep.
Okay, what'd you get?
I'm still in the process.
In the process, all right then.
17 times 7 equals
I don't wanna hear you.
119 divided by 5
You shut up.
23.8.
Are we good with that?
Yep.
All right, and maybe there's another way to do it. Maybe I made this segment here x minus 7 and then did that or that,
You're missing something too.
What am I missing?
Oh wait, no, never mind. I didn't see it. I thought you circled 16.8 for a second.
Okay,
Yeah, I would have checked a lot of people out.
I was glad I'm not missing something. We're freaking people out.
How did she?
Moving on.
I think my
All
series
right, so we got parallel,
activated my series.
set my phone.
Oh,
Oh, what do you think? We gotta label this thing, right?
It's a lie.
Oh, this is interesting, isn't it? Guys, this is interesting. EB is 3 more than DB.
CO back to 3.
EB, 3 more than DB. That's not a scale factor, that's not a multiple, that's addition, isn't it? It doesn't say it's 3 times the length. If it said 3 times, you might be onto something, right?
Smart.
So AB, let's get to the other stuff in there. AB is 14. 14. CB, 21. Okay? And they want us to find AD. So I'm going to put an X here on AD. So we got to think about this here a little bit.
Wait, and then is EB
bless your heart and soul. Amen.
Sure. Look at her. Let's think about this for a minute. So EB, right here, this is EB, right? Why? Wait, is 3 more than DB. Okay. We need to have something for DB to be able to express 3 more than it, right? So it's whatever DB is plus 3, right?
still gonna be like Y plus 3 then?
Well, that's another variable. We don't want to not have 2 variables, right? This whole side is 14. What's this section of it length there? So what's the length of this one? 14 minus x.
Which is 12.
All right, stick with me. No, I don't know. You know.
Because I'm just.
How do you know x is 3?
I don't
If
know.
you knew that was 12, you already know what x is, and the problem solved.
Yeah.
No. Okay, listen carefully. EB is 3 more than DB. This is 3 more than that.
Yeah.
So how do we write 3 more than 14 minus x? What? Times 3?
Plus 3.
Multiply
What plus
by
3?
14 minus X plus 3.
Minus x plus 3. Right? 3 more than. But let's simplify that. Can we simplify that?
It's 3 more than.
I know, that's what I have.
17
Oh. So can I, go ahead, 17.
minus X.
So it's 17, you guys see it's 17 minus x? We have to think about that a little bit, right? You with me?
Yep.
Did we lose anybody there?
Nope.
Yeah.
My brain cells.
So if I put an x here, right, and I know the whole thing is 14, well, the segment that's left here is got to be the whole thing 14 minus x, right? And then they tell us that the segment down here is just 3 more than whatever that is. Well, what is that? 14 minus x? What's 3 more than it? 14 minus x plus 3. And then we just combine like terms, right? You with me?
Sure.
No.
Now you can set up a proportion and solve for x. I'll give you a second.
Sorry.
So there's probably a different proportion to set up, but that'll work, won't it? You see how they're corresponding segments? All right, we got parallel lines, use the side splitter. Okay? Now just cross multiply.
I can't promise it'll be correct.
Like that? Finish it out. 238 minus,
Isn't it 17?
14x.
I got 8.
Minus, yeah,
oh, that's 17. Yeah, sorry. 238 minus what?
14,
14x equals what?
equals
294, 21x. All I gotta do is get all the x's on one side and add 21x to both sides. What's 14? Negative 14x plus 21x.
7x.
7x. Now subtract 238 from both sides. 56.
X equals 8.
I'm still trying to.
With me now?
Yeah, I just don't know how I'll separate those. But if you